Hello students and parents, hope you're doing well. We're going to continue using our protractors, making and naming acute and obtuse angles. We can start with a point out in space and draw a line from our origin and find out what angle that point is in comparison to a horizon. Or we can use our protractor and make a point using our protractor and then draw a line from our origin to that point, and we'll already know what the angle is. As well, we need to label our points so we can produce an equation for our angle that names that specific angle that passes through those 3 points. As well, we can use the equation to actually we can write an equation first and then identify that as a model or a diagram. So there's a lot we can do with just a protractor and a pencil, a few points, and I hope the students find this fun to do and interesting to complete. Okay, this is week 35, and we're looking at geometry, and we have this simple diagram with a line down here and a ray going perpendicular straight up from this horizon, this line here that goes to left and right. We learned that this particular line, this ray that goes straight up, is 90 degrees, and we can put a little box in there. You can't make a square with any other angle. When we draw angles, this is the only one where you can make a little box like this. Okay, and that's only because it's perpendicular. And we know just by memory that this is 90 degrees, and it's called a right angle. And then we discovered that over here, anything that is in this field over here to the right of this right angle, and is going to be less than 90 degrees as far as the measurement using our protractor. So an acute angle is less than 90 degrees. And then anything over here in this area is going to be greater than 90 degrees. And we call this greater than 90 degrees an obtuse angle. So we have a right angle right in the middle, we have a acute angle on the right, and we have an obtuse angle on the left. Now, we also learned that in this particular instance, where these two lines, where this ray and this line intersect, this point right here, okay, is where all our angles are going to originate from. So we call that the origin. And that's a very important term because you're going to come up with this quite a bit in middle school and high school, this origin. And then we found out that we could put a point out in space. And let's say we have several points out in space. If we just want to identify one particular point, we can actually give it a name and call it by a capital letter A. And we gave other points names. We named this one B, and then we create another point over here, this one called C. So to name things, you have to use a letter, and you can put a point out anywhere you'd like, just as long as you give it a name, someone knows what point you're talking about. Then we took our pencil and set it on the origin and drew a ray to that point, like so. You got to put an arrow on there, and this shows that this whatever it is, whatever unit it is, it started from this origin, it's going that direction. So let's say you threw a rock, starts from the origin from where you're standing, and it goes that direction. Let's say you're a star. You started from a galaxy over here, and you're going that direction. That's what a ray is. It starts from an origin and goes just one direction. And then we said, okay, well, how do we tell what angle this is? How do we tell what angle this point is going, what direction is this point going in? What angle is it going in? And that's where we came in with our protractor, which is a ruler, but it's a half circle. Okay, and this one's marked by 10s with 1s as the little marks in between. And we have this horizontal line just like we have here. We have our 90 degrees at the top. And if we line those all up, here's our origin here. We're calling this the target. Put that on B, line up our 90 degrees and our horizon like so. We could tell what this line, this ray is going to be. So this ray is extending from the origin at 35, 36, 37 degrees. And we can identify that, what did I say, 37? Yeah, 37. Oh, my pencil dug in. It's nice and sharp. 37 degrees. So this model, this drawing, shows us that we started from this area, and this is how we measured our 37 degrees using our protractor. And then we learned that, hey, you can actually name this angle in kind of like an equation. We have this symbol here for that represents an angle, so it looks like a little acute angle. We use the same symbol for both sides. We don't use a different symbol for obtuse angles. And we can name this angle ABC. That gives us the angle that we're speaking about, just like when we name just a point. And that we could actually make an equation and say this angle is equal to 37 degrees. So that's everything we learned in our first lesson, and that is quite a bit. It all makes sense. It's all very logical, but there's a lot of information going there. And if you take it just step at a time, I think you'll do well. So on this side, we could actually write this equation and then make the drawing. Just like when we do word problems, you could start on the equation, you could start on the drawing, you can start on what's known. So over here, let's make an angle. B is going to be part of it, and let's make another point over here. Let's not make a point over there. We're going to save that for maybe later. Let's keep this BC point down here, and let's start with point D, DBC, and let's say it's going to have to be greater than 90 degrees. Let's say DBC equals 142 degrees. So we could actually start with this equation on this side, and then we could draw our drawing over here depending on our equation over here. Now, since it gave us a specific angle, we can't just put a point out in space. We have to find that point using our protractor. So go ahead and try and find that point using your protractor. Go ahead and stop the video and see if you could be successful at that. So how did you do? We were given this angle. Let's use our protractor. Let's try and find 42 degrees first on our protractor. We can't put this point out in the middle of nowhere because it gives us a specific angle, so we're going to need our protractor. And we find 42 degrees. We know it's going to be to the left of the 90 degree right angle here. We say 42, 1, 2. I always like to put like a little point where 42 is and make the point just a little bit larger. Okay, now we're going to draw a ray out to this point from the origin. So we use our protractor again. I hope we don't mess up this time. Not bad. And then we measure our ray. Just kind of double check. That's not bad. That's not bad. 42 degrees. Now, if you notice, there's other angles here. There's an angle that's here. There's an angle that's here. There's an angle on this side. We always have to identify what angle we measured from. I'm measuring from my right side over here all the way over to this angle. So this diagram shows me where I measured, where I started from and where I went to. And this angle is 42 degrees, or 142 degrees. Now I have to name this point. Remember, there's a lot of points here. We want to give this point a name. I have to look back here at my equation and say, DBC. Here's C, here's B. This one has to be D. And that's how we identify an angle from an equation. So we can identify an angle as a point out in space, and its angle from the origin, and draw a ray going the direction from the origin out past that point. We can identify an angle by starting with a protractor and putting a point down and already knowing what that angle is going to be, and then drawing a ray from our origin. Or we can have an equation for an angle and then use our protractor and draw that equation for the angle. So your worksheet's going to have either an angle or a point or an equation, and you have to complete the drawing, and the drawing here, the model, has to agree with your equation here, just like when we do word problems. So good luck with that.